A diode is a two-terminal electronic component that conducts current primarily in one direction and blocks it in the other. This unidirectional conductance allows a diode to convert alternating current to direct current, emit light, and regulate voltage. A diode can be compared to a check valve in a plumbing system. Just as a check valve allows water flow in only one direction and prevents backflow, a diode allows electric current to flow in only one direction and blocks it in the other. This unidirectional property is crucial for converting AC to DC and various other electronic applications. Semiconductors, such as silicon and germanium, can act as both conductors and insulators. At room temperature, a pure semiconductor behaves as an insulator. However, its conductivity can be enhanced by adding impurities, a process called doping. Adding a pentavalent impurity, like phosphorus, introduces free electrons into the semiconductor, creating an N-type material, where N stands for negative charge carriers. Conversely, adding a trivalent impurity, such as boron, creates vacancies, called holes, resulting in a P-type material, where P stands for positive charge carriers. When P-type and N-type materials are joined together, they form a p-n junction or diode. The plane where these materials meet is called the junction. Due to diffusion, electrons and holes move across the junction, creating a region depleted of mobile charge carriers, known as the depletion region. The movement of charges creates layers of positive and negative charges in the depletion region, setting up an electric field that stops the further flow of the diffusion current. These layers form an opposing potential across the junction, called the barrier potential. The barrier potential does not allow current to flow until the externally applied voltage exceeds its value. The value of the barrier potential is approximately 0.7 volts for silicon and 0.3 volts for germanium. The depletion region acts as a gatekeeper, exhibiting both insulating and conducting properties, controlling the flow of current through the junction, depending on the magnitude and direction of the applied voltage. If the positive terminal of a battery is connected to the P-type material and the negative terminal to the N-type material, the diode is in forward bias. This causes the depletion region to become thinner. At around 0.7 volts, called the knee voltage, the depletion region vanishes, and the diode fully conducts. Holes and electrons are pushed towards the junction, where they recombine, allowing current to flow with low resistance. Reversing the polarity of the battery puts the diode in reverse bias. Here, holes and electrons are pulled away from the junction, widening the depletion region, and acting as a barrier to the current flow, giving the diode a high resistance in this direction. Diodes have many applications in electronics, such as rectification, voltage regulation, and light emission. A diode converts alternating current to direct current by allowing the current to flow in only one direction. This process is called rectification. In an AC circuit, the current periodically reverses direction, whereas in a DC circuit, the current flows in only one direction. I hope this explanation helps you understand more about diodes and how they work. For related videos, click the I button or follow the link in the description. Thank you for watching.